Hey everyone! If you're a beginner looking to transition into back-end development, or maybe you're gearing up for a major technical interview, well, you are absolutely in the right place. Today's explainer is a total deep dive into the architecture of Node.js. We're going to unpack the official documentation together to really discover the exact vocabulary and structural concepts you need to level up your engineering game. It's going to be a great time, so let's get right into it. Okay, let's dive into this. Here's our roadmap for the explainer. First, what is Node.js? 2. Threads versus non-blocking architectures. 3. Event loop mechanics. 4. Scaling across cores. And finally, number 5, ecosystem security. Section 1. What is Node.js? The fundamental definition. Now, the official definition is kind of a mouthful. It says Node.js is an asynchronous, event-driven JavaScript runtime designed to build scalable network applications. Built on Chrome's ultra-fast V8 engine, what this actually means in practice is that it handles a massive number of connections concurrently. Every time there's a connection, a callback is fired. But here's the brilliant part. If there's no actual work to be done, Node just goes to sleep. It literally just sleeps, which saves a ton of system resources. And when you build on that runtime, it's honestly fascinating how it handles the web. HTTP is a first-class citizen here. It was designed right from the ground up with streaming and incredibly low latency in mind. This specific architectural choice is exactly why Node is so perfectly suited to serve as the absolute foundation for modern web libraries and frameworks. It is built for continuous, high-speed data flow. All right, moving on to Section 2, Threads versus non-blocking, the concurrency battle. And this brilliantly illustrates the great divide in backend engineering. Think of traditional OS threads, like a restaurant where a chef takes an order, waits completely idle while it cooks, and then serves it before ever taking the next order. I mean, it's inefficient and super prone to gridlock, right? Node.js, on the other hand, acts like a master chef. They take an order, get it cooking, and immediately pivot to take the next order while the first one is still on the stove. Because there are absolutely no locks, you don't have to worry about the nightmare of deadlocking your processes. It's just pure lock-free freedom. Which leads us to this incredibly powerful quote straight from the official docs. Because nothing blocks, scalable systems are very reasonable to develop in Node.js. That non-blocking I/O model, that is the secret sauce. It's the ultimate solution to bypassing those traditional OS thread bottlenecks. Section 3. Event loop mechanics. Unpacking the runtime construct. Now, this is a classic technical interview topic you really need to master. While systems like Ruby's Event Machine or Python's Twisted are, somewhat similar, Node takes it a massive step further. In those older systems, you usually need a blocking call, like an explicit run command, just to start the event loop. But look at Node. It presents the event loop as a native runtime construct. There is absolutely no explicit start the event loop call required at all. It just works. Let's move to and see how this builds out in the lifecycle step by step. Step 1, Node simply executes the input script. Step 2, it automatically enters the event loop natively. Step 3, it fires callbacks on each connection. Step 4, if there's no work, it intelligently goes to sleep. And finally, Step 5, it gracefully exits but only when no callbacks remain. You know what the best part is? All of this event loop behavior is completely hidden from the user, exactly like browser JavaScript. It all happens right behind the scenes. This familiar paradigm is literally why so many front-end developers feel instantly at home when they make the leap to back-end engineering with Node. Okay, Section 4. Scaling across cores. Multi-core processing without OS threads. This brings up a really fascinating technical question. It's one you are almost guaranteed to hear in an interview. If Node is specifically designed to be single-threaded without OS threads, how do we actually take advantage of multiple CPU cores for heavy workloads? So the crucial point is right here in the documentation, which provides a brilliant native architecture for this. Listen, being single-threaded doesn't mean you're stuck on one core. You can use the child process fork API to spawn child processes that communicate super easily. And building on that, the powerful cluster module lets you share sockets between those processes. This natively enables load balancing across all of your CPU cores. It's just an incredibly clean, elegant way to scale. Section 5. Ecosystem security. Navigating official resources safely. As a developer, ensuring a secure environment is absolutely crucial. The official docs are super clear on this. To stay secure, never trust emails or downloads from unofficial sources. Just don't do it. Make sure you're pulling your documentation and binaries only from verified domains like Nodejs.org, Nodejs.dev, or iojs.org. And for source code, always stick to official GitHub organizations like Node.js or PKJS. Oh, and report any issues directly to the Node.js website repository. That exact same rigorous standard applies to your dependencies, too. Look for official NPM package scopes like @nodecore, @pkjs, or packages published directly by the Node.js Foundation account. Sticking to these specific scopes is definitely the best way to guarantee you're building your app on verified, officially supported, and secure components. And remember, Node isn't just code. It's a massive, vibrant, open-source community backed by the OpenJS Foundation. I highly encourage you to use the Get Involved page to connect with them. Utilizing these official communication channels or keeping an eye on the real-time Node status page is a huge part of maturing from a beginner into a truly professional backend developer. Well, we have uncovered a lot today, haven't we? From the hidden magic of the event loop to multi-core scaling. So as you take all this new knowledge straight into your next project or that big technical interview, I want to leave you with this. Knowing how this non-blocking, lock-free architecture scales seamlessly across cores, what legacy threaded bottleneck are you going to replace first?